So normal at P to hyperbola of eccentricity E. Okay. Intersect, transverse, and conjugate axis at these 2 points. It's like this, right? So there's a hyperbola. And normal at P of hyperbola. Intersect. Right? So say this normal, intersect it at P. Right? And these points are LNM. Locus of midpoint of LM. Okay, so basically we need equation of normal, then we can
Yes, sir.
locus of midpoint.
Sir, can we assume any hyperbola then proceed?
You can do that.
Yes, sir.
You can do that. You can assume X, any hyperbola.
And we'll put the value of E accordingly.
Yeah, you can do that.
Yes, sir. Okay.
Can try that. Anyway, I'm just assuming general hyperbola, say a sec theta, b tan theta.
Yes, sir.
And equation of normal of hyperbola is basically a square x over x1 plus b square y over y1 is a square plus b square, right?
Yes, sir.
This is equation of hyperbola. And x1 y1 I just write a sec theta, b tan theta, that is ax over sec theta plus by over tan theta, and that is a square plus b square. Okay. Now, so there's the equation of normal, and if you put y equal to 0 and x equal to 0, you find coordinate of L and M.
Yes,
So
sir.
for L, we put y equal to 0, so that is it is sec theta into a square plus b square over a, right?
Yes, sir.
Okay. So a square plus b square over a into
Cos theta.
sec theta. So
Huh.
maybe you can write denominator as cos theta common second, right?
Yes, sir.
And m, if we put x equal to 0, so there is a square plus b square, denominator b, and sec theta 10. So here maybe you can write cot theta. Okay. And 0 comma. So we got L and M. Now we find midpoint. So
Yes, sir.
let's say
Sir,
midpoint
can we,
x is,
if
yes.
I was not able to know this equation of normal, then can we differentiate the general hyperbola and put that P point for finding normal?
You can. If you don't know what you can do, you can do by this way, right? You know equation of tangent at this point, right?
Yes, sir.
And that is xx1 over a square plus y1
Hmm.
minus y1
T
over b
equals
square,
to
right?
0. Yes, sir.
T equal to 0. And so now this, from that you can find equation of normal. Say any line ax plus by plus c equal to 0 is given. So its
Ye-
perpendicular line is bx
Bx minus
minus
AY
ay
plus
plus k
BK.
equal to 0,
Huh.
right?
Yes.
And it passes through these 2
Yes,
points,
sir.
these
Yes.
points. From that you can get this normal also.
Okay.
So that's also you can see. So L and M, so midpoint is h comma k, that is a square plus b square over a cos theta plus
Yes.
0 by 2. So divided by 2a cos theta. And this is a square plus b square divided by 2b
To be caught theta.
cot theta, right? So this is point h and k. Okay.
Yes, sir.
Now, what do we want? We
Locus
need
of
to
that.
eliminate, look for the relation between h and k. Just
Yes, sir.
eliminate this thing. So sec square minus tan square is 1. So we
Yes,
can
sir.
create second 10 from here. Like the sec theta is the cos theta. The sec theta is 1
2a
over
h
cos is
upon a
sec.
square plus b square.
Yes. 2h over a square plus b square. And tan theta
2bk upon a square plus b square.
to bk over a square plus b square. So now I will use x square minus 10 square 1. So x square is this 4h square or a square plus b square whole square minus 4 b square k square or a square plus b square whole square is equal to
1.
so instead of h we write x, instead of k we
Yes,
write
sir.
y.
Yes.
So it is x square over
A square plus b square whole square upon 4 square.
whole square over 4x minus y square over. So this is the locus, right?
Yes, sir.
Over 4b square. Now for hyperbola, our hyperbola was this x square over a square minus
Y-
y square over b
Yes, sir.
square equal to 1. Eccentricity is given by square root of 1 minus 1 plus b square by a square.
Yes, sir.
Or rather I can say e square is equal to 1 plus b
B
square by
square by
e
square.
square. Now let's say its eccentricity is e dash.
Yes, sir.
So that eccentricity is given by yes, e dash is equal to or rather e dash square equal to 1 plus b square. So b square is this, that is a square plus b square whole square over 4b square over a square. A square is plus b square whole square over 4a square.
4 square.
So that is 1 plus a square over b square.
Yes, sir.
Now from here, b square over a square is a square minus 1. So a square over b square we
1
can
upon
write
e
as
square.
1 over a square minus 1. This is 1 plus 1 over a square minus 1. That is e square minus 1 plus 1 over e square minus 1.
Yes, sir.
Yes, e square over e square minus 1. So e dash we get is e over square root of e square minus 1.
Yes, sir.
Yes, e over square root of e
Yes.
square minus 1. Right?
Yes, sir.
Okay, that's it. You can assume hyperbola
Yes,
normal
sir.
that will be fine, right? Next we have this question. So have you simplified this determinant here?
No, sir. I was unable to.
What you can think of? This is a standard determinant, right? You can remember the process for this thing. It's like this. What you do? X cube is there, x square y, x square z, x y square, x z square, right? So
Yes, sir.
you create cube, right?
Yes, sir.
Create cube. And to create cube, what you can do is you can take something common from column or row.
Yes, sir.
So here, if I take say x common from row, so here I take x outside. Here, if I take say y outside, and here if I take say z outside.
Yes, sir.
So what happens? Here it is y square, z square.
Hmm.
Here it is x square, z square, and here it is x square, y square. Now, after taking column, so outside is x, y, z, right?
Yes, sir.
So now what you do, you again multiply that x, y, z inside, but now you do it row wise. Sorry, column wise.
Yes, sir.
So it's like this. In the first step, what happens? It is like x cube plus 1 over x plus y. It's not plus y square z square. You have taken x, y, z common. And here it is x square y cube plus 1 over, you have taken y and here it is y z,
Z
so
square.
z square,
Hmm.
and same way from here, right? Here is x square, y square z, so y square, and z cube plus 1 over z, right? So there's x, y, z. So now that you have taken from common, now you multiply first column with x, second column with y, and third column with z,
Yes.
right? So this xyz again goes inside,
Yes,
yeah?
sir.
And this become x
X
cube
cube
plus
plus
1.
1, X
This is
cube
x
and
cube,
X.
right? This
Yes,
same
sir.
way, y cube plus 1, y cube, z cube, z cube, z cube plus 1. So what I'm doing now, just add in C1, you add C1 plus C2 plus C3.
Yes, sir.
So here you get x cube plus y cube plus z cube plus 1. Same thing here, same thing here.
Yes, sir.
And here remaining y cube z cube, y cube plus 1 z cube, y cube z cube plus 1. Now you take this thing common, x cube plus y cube plus z cube plus 1. Here it is 1, 1, 1, and same thing, y cube z cube, y cube plus 1, z cube, y cube, z cube plus 1. We can make maybe 1 or 2 0
Yes,
from
sir.
this, and then we will open it. X cube plus y cube plus z cube plus 1 into, let's do in R1, R2, R2 minus R1, and in R3,
R3 minus
R3 minus R1. That's I'm subtracting R1 from both. So first is same 1, y cube z cube. This is 0. R2 minus R1, so this is 1, this is 0, this is 0, y cube 0,
0, 1.
and this is 1. Okay. Fine, so you can open it from anywhere. So this is plus
Yes, sir.
minus plus minus plus plus. I'm opening from here. So that would be 1 minus this. So this is 1 only. Right?
Yes,
This
sir.
is 1 only. So what do we get? X cube plus y cube plus z cube plus 1. And now this is equal to
37.
37. Okay. Another x cube plus y cube plus z cube is equal to 36. Question is
36.
what?
Yes, sir.
They are asking us
Number of solution.
number of positive integral solutions.
Yes,
So
sir.
0 is not included. Okay. So you can say it's a cube is happening. So this xyz belongs to, it could be 1, 2, or 3. 3 cube is 27, right? 4 cube is 64. So it can't go beyond that thing.
Yes.
Right? So I need to think in this direction only. So let's start with 1. Okay. So I'm taking yz. So say x is 1, and if I put a y also 1, can I get z? 1 cube, 1 cube. So 2, and 36 minus 2, 34. So no, I don't get thing, right? So 1,
Yes,
1
sir.
not possible.
Yes.
Let's check with 1, 2, right? So
Yes.
1 plus 8, and if I do 36 minus 9, we get 27, which is 3
Yes,
cube.
sir.
Okay, so we got this thing. Okay. Now let's check 2, 2, right? So 2, 2 is 4 and 4, 8, and 36 minus 8.
Sir, 8 plus 8.
What is saying?
Sir, 8 plus 8. 2 cube plus 2 cube.
Oh, sorry, I did 2 on square. fine. So if let's say 16 and 36 minus 16,
20. No, sir.
we get 20. Okay, so that's also not possible, right? So obviously 3, 3 is also not possible. So we get this thing only.
Yes, sir.
Okay. So basically x, y, z, we have 1, 2, 3. So they can be arranged internally in 3 factorial ways.
Yes, sir.
So 3 factorial ways means 6 ways. They can be arranged. So total 6 integral solutions are there.
Yes,
Correct?
sir. Sir, one method was taught to us that one direct formula was told to us that number of positive integral solutions of the equation x1 plus x2 plus x3 dash 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 xr equals to n is n minus 1 c r minus 1.
Yeah. N plus
So,
r minus 1, c r minus 1.
uh, yes, sir.
It's beggar's
Sir,
method. Beggar's method. Huh?
so can we apply that?
No. The
Why,
reason
sir?
being here x cube, y cube, z cube is there, not x, y, z.
Sure.
You can.
Yes.
If x, y, z would have been there, then you can do this.
Yes. Sir, we can't assume x cube, y cube, z cube as p, q, and r.
No, because they doesn't behave that way.
Yes, sir.
You cannot take otherwise that doesn't behave that way, right?
Yes,
X
sir.
cube cannot be 2, x cube cannot be 3.
Yes, sir.
Is that? Yes. A, B are this, a vector, B vector is given. X1, X2, X3 is this. Number of possible vector B vector, A dot B is 0, right? So if you take A dot B equal to 0, you write X1 plus X2 plus X3, right?
Equals to 0. Yes.
0. And X1, X2, X3 lies in this thing.
Yes, sir.
And they are asking you possible vector. Okay, so again we need an ordered pair x1, x2, x3.
Yes,
that
sir.
will be number of vector. Okay. So okay, so here also we need to take cases only. Here I can do this directly because negative numbers are also there,
Yes, sir.
right? So let's try with this. Let's take a x1 as minus 3. So x2 and x3, I can have 1 and 2.
Yes, sir.
The 1 plus 2 minus 3 is equal to 0. So from here we get 3 factorial ways.
Yes, sir.
6. If I take x1 minus 3, I would again. Okay, with minus 3, is there any other possibility? No, no other possibility.
No, sir.
Okay, suppose I take say minus 2, and I will start with this range. So if I take minus 2, then this could be 1 and 1 is one possibility.
Hmm.
And both are 1. So that is 3 factorial over 2 factorial.
Yes, sir.
3 ways.
0 and 2 also.
Okay. Yeah, and minus 2 with 0 and 2 is also possible. Yes. Minus 2 with 0 and 2 also possible. So this will be 3 factorial, 6 ways.
Yes, sir.
And then we have, let me write it down. Then we have minus 202. Okay. Is there any other possibility with minus 2?
Minus 2 plus 3. No, sir.
No, minus 2 and 2 and 0 we have taken, right? Minus 2.
Yes, sir.
Minus 3 is not. Okay, fine. Now let's check with minus 1. So with minus 1, what can we have? 0 and 1.
Yes, sir.
So that will be 3 factorial. 6. And anything else? Minus 1 we can have.
Minus 1, 2.
Minus 1, 2. Okay. Well, that's again 3 factorial over 2 factorial. 3. Anything else?
No, sir.
Okay. Then one more 0, 0, 0. That
Yes,
is
sir.
1. Right. And after that 1, 2 we have already taken in this, and everything has come. So
Yes.
I think so. This will be the number of ways.
25.
25 should be there. Right?
Yes, sir.
Here you have some doubt in answer
No, sir.
or
No, sir.
it's
Full.
full? Okay. Bag A contains 5 white and 5 black balls. So this is bag A, which is having 5 white, 5 black ball. Bag B is an empty initially. 5 balls are drawn from A, placed in B. 4 balls are drawn from B, placed in C.
Yes, sir.
Probability that C contains exactly 3 white balls. Okay. So from here, first you are removing 5 balls.
Yes,
So
sir.
there are 3 cases is possible that from bag A you are taking 3 white ball, 4
Yes, sir.
white ball or 5 white ball.
Hmm.
Correct. So these 3 cases are possible. So case 1, from bag A you take 3 white ball, right? So what's the probability when you take 3 white ball? It is from 5 you take 3, from 5 white ball you take 3 white ball,
Yes, sir.
and from 5 black ball you take 2 black balls,
Yes, sir.
and in denominator it will be actually
10
you are
C3.
taking
10 C5.
10C5. Huh? So once you do this, in bag B there are 3 white balls and 2 black balls,
Yes, sir.
and now you are drawing 4 balls and you want exactly 3 white balls
Yes, sir.
and 1 black ball. So 3 white ball from 3 white ball in
1 K.
3C3
3
ways,
C3.
2 white 2C1, and in
Yes, sir.
denominator
5
4C
C4.
5C4. So this case is over.
Yes,
So
sir.
this into this is this probability.
Yes, sir.
Similarly, you do case 2, where from A you are taking 4 white ball. Correct. So why 5 white 5 black? A you are taking 4 white ball, that can be done in 5C4, and remaining one will be black, 5C1, denominator
10 C5.
10C5. So once you do that, in bag B there will be 4 white ball,
1 black
sorry,
ball.
yeah, 4 white and 1 black. Now in bag C you are taking 4 balls and you want exactly 3 white ball and 1 black ball,
Yes, sir.
right? So that can be done in 4C3 and 1C1,
Yes, sir.
and denominator 5C4.
4.
This thing. And if I do case 3,
All 5 white.
yeah. So from A you are taking all 5 white, but here we won't get anything. As you say, if you do 4 5 white, so here 5 white will be there. So here, if you take 4 balls, it will be 4 white only.
But we want 3 white.
We
No,
want 3. So this case doesn't
exactly
count.
3 we want.
Exactly. So this case doesn't count. Right? So case
Yes,
1
sir.
and case 2 are only suitable. Right. So yeah, so that's it. 5C3 into 5C2, that is 10 into 10,
100.
100, over we had 10C5 times This thing is
2.
1 times 2, 2 over 5 times 2 over 5 plus second case. Second case is 5c4, 5c1, that is
25.
5 times 5, 25, huh? Or 10c5. And this thing is 4
4.
over 5c4, 5. Right?
5.
5 5s are 25 getting cancelled. Yeah, 25s are 100 getting cancelled. So
60
fine.
upon 10c5.
Yeah, so 60 upon 10c5. Correct?
Yes, sir.
Yeah, so 60 is the answer, right? K over 10c5.
Yes, sir.
So this diagram helps in means specifically in question of probability.
Yes, sir.
Next we have sigma r equal to 1 to infinity. So 12 r cube square plus 1. Denominator is 64. 64 is 4 cube.
Yes, sir.
4 cube. And this is 1. So if you just think about 4x minus 1 cube, so it will be 64 x cube minus 3a square b, 16 3s are 48 x square plus 3ab square, 3 4 3s are 12 x. So it's actually same pattern, right? 64 48 12 and
Yes,
1.
sir.
So this thing is 12, sigma r equal to 1 to infinity 12 r square plus 1, and denominator is 4 r cube minus 1 whole cube, 4 r square minus 1 whole cube, right?
Yes, sir.
Now 4 r square minus 1. Okay, so here I can write this thing as 2r plus 1, 2r minus 1. And numerator is this 12r square plus 1. If I think of creating difference of denominator in numerator, right?
Yes, sir.
So what will happen? It's 2r square minus, just a minute, a cube, 6, okay. It's a plus b, a minus b, 2r plus 1 cube, 2r minus 1 cube. So direct 2r plus 1, 2r minus 1 is not happening.
No, sir.
Let's take a cube only. So if I do 2r plus 1 cube minus 2r minus 1 cube, so what happened? 4r cube, sorry, 8r cube, and then 2ab, 3ab square, 3 into a square b, 3a square b, 3 into 4, 4 3s are 12, r square plus a square b, 3 a square
AB
b,
square.
3 ab square. Ab square means
6 r.
6r plus 1. Okay. And this thing is minus 8r cube, alternate plus negative, minus 12r square plus 6r minus 1, right? 8r cube get cancelled. So we get 24r cube, r square, 6r get cancelled, and we get plus 2.
2. Yes, sir.
So same thing, it's just need to one more 2. So if I write 6 here, so sigma r equal to 1 to infinity, and this is 24 r square plus 2. Denominator same thing.
Yes, sir.
So this is 6 sigma r equal to 1 to infinity, and this thing we can write as 2r plus 1 whole cube minus 2r minus 1 whole cube, and denominator same thing. Whole cube, 2r minus 1 whole cube. And if we separate this thing, that is 6 sigma r equal to 1 to infinity 2r plus 1 over this, so 1 over
2r minus 1 cube.
minus 1 whole cube minus 1 over 2r plus 1 whole cube. Right now it's in difference form, so
Yes,
we
sir.
just put r. So if you put r equal to 1,
1 upon
1
1
over
minus
1 minus here you put r equal to
0,
1,
1
1
upon
over
0. 1 upon
um,
infinity to 0.
2 2 plus 1 3, 1 over 3 cube, right? Plus something else, 1 over 3 cube will be here, right? If
Yes,
you
sir.
put 2, so minus something, and since it's up to infinity, only first term will come,
Yes, sir.
that is 6 1. So answer is 6 times 1 6.
Yes, sir.
Correct?
Yes.
6 answer is. This question. The point P moves in such a way that angle APB is 60 degree, 30 degree, pi by 6. A is this, B is this. Area bounded by locus of P is lambda. Greatest integer less than or equal to lambda by 10 is what? Okay. So if I draw a line like this, so this is A, is B, 4 0, and this point is set P, and this angle is 30 degree, pi by
Yes,
6.
sir.
So basically what we can think about, we can find slope of this line, slope of this line. Let's assume this point is x comma y, this is origin. And we know the formula tan theta is equal to m1 minus m2 over 1
Yes,
plus
sir.
m1 m2, right? So I'm using that thing. So slope of AP is a y by x. Slope of PB is y by x minus 4. So tan theta, that is tan pi by 3, pi by 6 it was. M1 minus M2. So I'm just taking positive value. So
Yes, sir.
this is, denominator is smaller, so this number will be bigger.
Yes,
So
sir.
I'm putting that first, y over x over 1 plus M1 M2. Correct?
Yes, sir.
So from here, what do we get is 10 pi by 6, 10 30 है 1 by root 3 is equal to, there is if I take y common, there is x minus 4, denominator x square minus 4x plus y. Correct?
Yes, sir.
Y square basically. Okay. So this is nothing but 4y over x square minus 4x plus y square. Okay. Now let's do cross multiplication. So it is x square minus 4x plus y square is equal to 4 root 3y. Now just to try to make perfect square, x square minus 4x plus 4, y square minus 4 root 3y is there. I add 4 this side. So here I need to add half of this 2 root 3, square of 2 root 3. So I need to add the same thing over here also, right? So I am just completing the square method.
Yes, sir.
So what we get is, this is x minus 2 whole square plus y minus 2 root 3 whole square, and that is
16.
4 plus 16, that's 16. It is 4 square. So this is a circle.
Yes, sir.
The question is, the area bounded by locus of P is lambda. So area is pi r square, circle it is, right?
Yes, sir.
Then greatest integer less than or equal to lambda by 10 is what? Eh? So area is pi r square. That is 16
16
pi.
pi.
And they are asking us a box of 16 pi by 10. What are we getting this?
22. F. 1.6.
You can write 3.1 for them rather than 22.
Yes,
That's
sir.
fine.
1.6 into 3. 4.9. Sir, 4. It's no. 1.6 into 5. It's coming.
You just need approximate value. Eh? Pi, you can take 3.1 also. No issue. Eh?
Yes,
What
sir.
are you getting?
3.1. 1.6. 16, 18. 1, 3, 8, 9, 4.96.
4.96.
Yes, sir.
Okay. Let me verify this thing. Sixteen times 3.14 equal to this 50.24. 5.024 we are getting. Correct.
Yes, sir.
So it's very close basically. 5.024. So that is 5.
Yes.
Right? So answer is
Yes,
5.
sir. Sir, I had one more doubt. Can I send it
Tell me.
in the chat section? One minute, sir. Sir, can I send image here in the chat?
You can try. I'm not sure.
Okay. Yes, sir. Yes, sir. Yes, sir. I sent. Sir, here I had a specific doubt that can we do by that method that greatest integer function is discontinuous at all integers? So by
Hmm.
seeing that in the domain -2 to 2.
Hmm. See, number of point where function is not continuous. Okay. Box x mod x square minus 1 sine box x plus 3 minus box x plus 1 x minus 2 to 2. Function it is not continuous. Okay. So let's you need to think about say you take different point, right? And the mainly problem is at integer, suppose, right?
Yes, sir.
So suppose you check at
If I
say
see for integers only -1, 0, and 1 are allowed in this domain.
yeah. So suppose you take minus 1, right?
Yes, sir.
So at minus 1 this is discontinuous.
Yes, sir.
Let's use simple boxes there, right?
Hmm.
Minus 1, so this thing if you can check, so if you put a number just less than -1 and just more than -1,
Yes, sir.
and the -1 minus, so it becomes -2, so this becomes sine of pi over
Uh,
3 minus 2,
hmm.
that is 1.
Yes,
And
sir.
if you put -1 plus. huh? So that is 0 point
Pi
something,
by 2.
minus 0 point something. So that become -1. So pi by 2, sine pi by 2. Okay.
1.
So this function sine pi by 2
Discontinuous.
and pi. So this is again a discontinuous.
Yes,
It is
sir.
giving different values.
Hmm.
Now you think about, so discontinuous plus discontinuous, discontinuous, no issue with that.
Yes, sir.
And this box x mod x square minus 1, right? Here also you can check if you put just less than -1, that is -2.
Yes, sir.
And this x square minus 1, x square minus 1 is anyway continuous, so it doesn't have an issue, right?
Yes, sir. Mod is continuous.
Yes, so it is continuous. Yeah, so it -2, I think this also should be discontinuous.
Yes, sir.
Okay, so this, so if I talk about 0, so 0 it is plus or minus. I have to check it probably, I'm not sure. Have you tried it? Means at a
Yes, sir. I
-1,
have
0 and
tried.
2, 1.
I have tried.
Yes.
I am getting that the function is discontinuous at all the 3 points -1, 0, and 1, but they have given discontinuous at only 0 and 1.
Only 0 and 1. Because at -1 it is continuous.
Yes, sir.
We put -1 here. This was maybe by combining them, it should be happening. So let's do it proper way में मैं कर लेता हूँ. This f of -1 है ना, -1 minus I am doing, right? -1 minus means I am putting -1.1 suppose है ना,
Yes,
-1
sir.
value I'm putting. So this box x become what you can say -2.
Yes, sir.
There is x square minus 1, I'm writing as it is, plus sine pi over box x, that is -2, 3 minus 2, 1. So it's sine pi, which is 0, minus, if you put -1.1, -1.1 plus 1, which is -0.1, that is -1, right? So this is -1, correct?
Yes, sir.
Right? It's -1 on there. Head and correct. X is -1.1 plus 1, -0.1, -0.1. So that will be minus, correct. Right. So if I check this value, that is sine pi is 0. So that is -2 mod x square minus 1. And this is plus 1. And since it's just x is just less than -1, right? So this you can write like this: x plus 1, x minus 1, plus 1, minus 1, 1, plus minus plus. The x is just less than -1.
Yes, sir.
So this mod open positive, right? So it is
Yes, sir.
-2 x square minus 1 plus 1. Or it is simply -2x square plus 2 plus 1, or x is -1 only, right? So -2 plus 3. So we are getting 1.
Yes, sir.
Now similarly you check it f of -1 plus, right? So that thing you can check. -1 plus means you are putting say 0.9 in this.
Yes, sir.
So if you put say 0.9 in this, so this become minus 0.9, minus 0.9, so this become
minus
minus
1.
1, and mod x square minus 1 plus sine pi by 2, and pi by 2 is
Yes,
1
sir.
only, minus, if you put minus 0.9, 1 minus 0.9, 0.1,
0.
0.1, so it will be 0. Okay. So that is minus, and since it's minus 1 plus,
Hmm.
so
Sir,
minus
can't
1
we put
plus,
minus 1 directly inside the mod of value of x inside the mod?
no, I need to check this thing, and it's positive or negative, mod x square minus 1. When x is just more than minus 1, x square minus 1 is negative. And x square minus 1 is negative. So I need to open the bracket, then I'll put the value
Yes, sir.
like this, right? So it's opening negative. Okay, this minus was there only. This open negative plus 1, which is minus 1 plus x square plus 1,
Hmm.
right? So if I put x, now I can put minus 1. Right?
Yes, sir.
So there's 1 only. Right? So both we are getting same thing.
Yes, sir.
So that might be the reason. Whereas normal theory, so basically individually they are there and discontinuous, but if you combine them, it's 1 only
Yes, sir.
for all of them.
Okay, sir.
Right?
Yes.
Oh,
Okay. Okay. Thank you, sir.
yeah, yeah, yeah.
Bye, sir.